Welcome to our course on the greatest unsolved mysteries of the universe. I'm Brian Schmidt.
And I'm Paul Francis.
We're both astronomers here at the Australian National University's Mount Stromlo Observatory. And Paul here is an expert on quasars. We're going to learn more about quasars. They're some of the brightest, most exciting objects in the sky. But Paul also works on things closer to home, comets, trying to understand how the comets that we see and how they tell us about those that we don't see. And finally, Paul also studies galaxies, huge galaxies, primordial galaxies in the early universe that we still don't really understand very well. So Paul really is an expert in mysteries.
Brian started off his research as a PhD on studying supernovae, which is how stars explode. And then when he came to ANU, he started using these supernovae to measure the expansion of the universe and how it's changing, and came up with a totally unexpected result. The universe was expanding faster and faster and faster, which led to the discovery of dark energy and a Nobel Prize, and Brian losing all his spare time. Since then, he's been working on gamma ray bursts, these mysterious flashes of gamma rays that flood through the solar system on a regular basis, and tracking them down like crazy, continuing his work on supernovae. And he's now also involved in commissioning a new telescope that's going to carry out the first digital survey of the entire southern sky and discover all sorts of interesting stuff.
So Paul, in this course, we're doing things a little differently. Normally when you do a course, you study all that you know about the universe or about the subject. And in this course, we're taking a slightly different tack. We're looking at the things we don't know.
And there are two reasons for that. One is because you hear most press releases about astronomy. It's always, astronomer discovered this, NASA discovers that. And that's because we like to look smart and brag, and we're really saying, please give us more money. But the second, that gives a false impression that we actually know most of the things about the universe, which is very far from the truth. We're actually extremely ignorant. And we're not doing badly, considering we're barely evolved monkeys and some average star on the outskirts of a boring galaxy, but we really don't know very much. The other reason is we want this course to tell you about what it's like to be an actual researcher in the field. And researchers don't research things that are known. By definition, research the things that we don't know.
Yeah, in the words of Einstein, if we knew what we were doing, it wouldn't be called research.
So that's what we're going to focus on. 9 of the greatest unsolved mysteries of the universe, things we don't know the answers about, things that are all active topics of research, and in fact things that we ourselves are researching.
And this course is at a level that's a little beyond the average documentary. It really is going to require some knowledge of maths and physics, at science at the high school level.
Yes, so we'd expect you to be reasonably comfortable with doing algebra and basic physics, things like heat, energy, Newton's laws of motion, things like that. If you're not sure about whether you're going to be able to handle the course, have a look at the homework in the first session. If that's looking feasible, then it doesn't get any harder than that, so you should be on track for the entire course. Let me show you how the course works. The most important part of the course web page is this courseware tab over here. Here you will see all the lessons. There's one section for each week of the course to begin with, 9 sections in all. A new one will be revealed every week. Within each section there is a lesson, which is kind of like a lecture or a class. And this will consist of a number of videos, which you can play.
Welcome to this, our first lesson, where we're going to explore what is arguably...
You can change the speed. That one was playing at double speed. If you want to slow us down, you can go down to half speed. You can change the resolution. You can also download the video or show a transcript, or download the transcript. So have a play with all of those things. After each video, there is a typically multiple choice question to test what you've learned from that video. Going through one of these lessons should take you about an hour. You don't have to do it all in one sitting, you can do it by bit if you like. The next important thing is the homework assignment. This contains more mathematical questions. We actually type equations or numbers into the boxes. Each homework assignment is due 2 weeks after the section is first made available to you. You can see the due date over there. If you want some help in doing the homework, we have reference notes which are a summary of the key facts from the videos. There are worked examples. These are videos of how to solve different sorts of problems. And there are practice questions. Again, not worth anything, but these are a chance for you to try out your ability to solve the sorts of problems before you get on to the actual homework. In the actual homework, you get 3 chances to get any given question right. Finally, there is a mystery. This will build up week after week. It's a universe very different from our own, which has 2 stars in the sky instead of 1. And the nighttime sky is full of bubbles. After we've finished going through the 9 lessons, you will then have a few weeks to try and piece together all the clues that you've learnt from this mystery and write up your solution for that, which is worth 40% of the marks from the course.
So I think that's most of what you need to know to do this course.
If you have any more questions, you'll see there are reference notes here in the introductory section, and also just post something on the discussion forum and we'll answer your questions if there's anything that's unclear.
All right, so let's go on to our first section where we look at the expansion of space.